f of x equals 3x squared minus 9x minus 30 divided by x squared minus 2x minus 15. We want to find any intercepts, asymptotes, and holes that the function may have, and then sketch the graph. So it's definitely reasonable just to start off by factoring. So in the numerator, I see that every term is divisible by 3, so I'll factor 3 out. Gives me x squared minus 3x minus 10 over x squared minus 2x minus 5 factors into x minus 5 and x plus 3. We can take the numerator a step further. This is 3 times x minus 5 and x plus 2. And then again over x minus 5 and x plus 3. So notice that my x minus 5 factor will cancel out. Since it cancels out, then x minus 5 equals 0, and I have x is equal to positive 5, creates a hole on my graph. So now I've pinpointed that, so I'll go ahead and cancel out, and I'm left with 3 times x plus 2 divided by x plus 3. This is the simplified form of my rational function. From this now, the denominator that remains will give me any vertical asymptotes that I may have. So if I take x plus 3, set it equal to 0, then I end up with x equals negative 3, and this is a vertical asymptote. Also from the simplified version, we can actually find the coordinate for the hole. So I know the x value, 5, I'll have a hole, but what is the y value? So in order to actually find the coordinate of the hole, I'm going to take the 5 and plug it back into the simplified version. So I have 3 times 5 plus 2 over 5 plus 3. Gives me 5 plus 2 is 7, times 3 is 21, over 8. So I know the actual coordinate for the hole is 5, 21 over 8. So here's the hole. Here's the vertical asymptote. So I'm just going to keep on with my simplified form, so 3 times x plus 2 and divided by x plus 3. Finding now the horizontal asymptote, if you notice the highest exponent in the numerator is the same as the one in the denominator. If I multiplied 3 times x plus 2, I'd just get 3x plus 6, so the highest exponent would be 1. Likewise in the denominator, so my horizontal asymptote since the exponents are the same, the horizontal asymptote is just going to be y equals the ratio of the leading coefficients. So in the numerator, I have 3x, my leading coefficient is 3. And in the denominator, I just have 1x, so the leading coefficient is 1. So my horizontal asymptote is y equals 3. Now to find my y-intercept and my x-intercept. So my y-intercept, if I take 0 and plug it in for x, I'm going to get y equals 3 times 0 plus 2 divided by 0 plus 3. 0 plus 2 is 2 times 3 gives me 6 over 3, which is equal to 2. So my y-intercept is 0, 2. And this would be the same exact value you would get if you found the y-intercept from the original function. So you can do it either way. You can find it right off the bat, or you can wait until you have it in simplified form. You will get the same value. So if you just want to go ahead and simplify the function first and find everything that way, it's totally a perfectly good way to do it. So there's my y-intercept. So finding my x-intercept, I'm going to take the function and set it equal to 0, which is the same as setting y equal to 0. So I have 3 times x plus 2 over x plus 3 equals to 0. My common denominator here would be x plus 3. So I multiply both sides by x plus 3. On the left, my x plus 3's would cancel out, leaving me with 3 times x plus 2 equals 0 times x plus 3 is just 0. Divide both sides by 3. My 3's cancel out, and I end up with x plus 2 equals 0 over 3 is 0. So x is equal to negative 2. So my x-intercept, sorry you couldn't see that, my x-intercept is negative 2, comma 0. So there's my x-intercept, here's my y-intercept, my horizontal asymptote, the whole, and the vertical asymptote. So I found everything that the question asked for, so I can go ahead now and sketch my graph. So y-axis, x-axis, and now just plotting all the information that I have. So I know I have a vertical asymptote at x equals negative 3. So I'll go to negative 3 on the x-axis and draw my dotted vertical line. And my horizontal asymptote is at y equals positive 3. So 1, 2, 3. And boop, 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 boop. Horizontal dotted line. I know I have a whole at 5, comma 21 over 8. So 1, 2, 3, 4, 5. 21 over 8 is 2 and 5/8. So roughly 2.5. Let's just say 2.5. So at 5, I'm in between 2 and 3. So somewhere around here, I have a whole. My y-intercept is at positive 2. My x-intercept is at negative 2. And so now, since all of my points are right here in the bottom right, I'm gonna safely assume that my graph goes right here. But let's test either side of my asymptote just to see what that looks like. So I'm trying to figure out on the right side of my vertical asymptote, so just on the right side of negative 3, what is my graph doing? So I'm gonna take a point that's just on the other side of that asymptote. So let's say negative 2.99. So I'm going to plug in negative 2.99 to see what kind of value I get. So if I plug in negative 2.99 into the simplified form, I'm going to have 3 times negative 2.99 plus 2 over negative 2.99 plus 3. So on the top, negative 2.99 plus 2, this is going to be something. 3 times negative 0.99 over negative 2.99 plus 3 gives me 0.01. So 3 times negative 0.99, I don't have my calculator, so I'm just going to come over here off to the side and do that. 3 times 7, 7 carry my 2, 2. So negative 2.97 divided by 0.01, which gives me negative 297. So I know just to the right of my asymptote, I'm way down here, it's going to be absolutely off my graph at negative 297. This is a good indicator that this portion of the graph is going to be going down to negative infinity at this asymptote. So I'm just going to follow it around, my x-intercept, my y-intercept, and I need to skate just below my horizontal asymptote. And so my guess here is that I'm going to be in the top left, but I'm going to go ahead and use my asymptote to figure that out. So on the left-hand side of negative 3, what is my graph doing? So I'm going to take a point just boop to the left of negative 3, let's say negative 3.01, and I'll plug that in. So I'm going to plug in negative 3.01. So I get 3 times negative 3.01 plus 2 divided by negative 3.01 plus 3. Again, I do not have my calculator. So 3 times negative 1.01 divided by negative 3.01 plus 3 gives me negative 0.01. So a negative divided by negative gives me a positive. So I have 3.03 divided by 0.01, which gives me 303. And of course, if you have a calculator, you can plug that in and check my work. I'm pretty sure I'm right, but no harm in double checking. But so what does this tell me? At negative 3.01, which is just to the left of my asymptote, I'm already at positive 303. So that means that right here, I'm already way off my graph at positive 303. You can't even see my hand anymore. So that's a good indicator that on the right side of my asymptote, I'm going to be going off to infinity. So again, I'm going to skate across my horizontal asymptote. And as I approach my vertical asymptote, I'm going off into infinity. So there we go. There's the sketch of my graph.